are made small so that my mouse is bigger. But anyway,
all right, don't not to worry. It's perfectly fine.
Yeah.
I'm using a Unix box. So
oh, you're on Unix. Okay, well maybe that's
Unix. What do they call it?
Okay.
A
proper computer rather than these toy things that we all.
Quite right too.
Yeah. Right, so I'm going to mute everybody, and then Anton, you just unmute yourself.
Okay, can you people hear me?
Yeah, that's fine.
Oh,
yes,
okay,
yeah.
fine. Anyway, today's presentation called Project Poincaré. It is in two parts. The first part is some observations that I have made or others have made. And the second part is what I call Project Poincaré. Okay, to start off with, some of you have heard this. I presented this 2 years ago already, and I think it's good to present this again. This is Oliver Scott from the University of Oxford, who wrote about fallibilism. And fallibilism is the idea that we can never be 100% certain. We write at and must therefore always be open to the possibility that we're wrong. This might seem a pessimistic notation, but it isn't. Ironically, this apparent weakness is strength. Admitting one mistakes is the first step to learning from them and overcoming them in science and society. Fallibilism lies at the heart of scientific enterprise. Even science's most well-established findings, the laws of nature, are but hypotheses that have withstood scrutiny and testing thus far. The possibility that they may be wrong or superseded is what spurs the generation of new alternative hypotheses and the search for further evidence, enabling us to choose between them. This is what scientific progress is made of. Science is rightly champions of winning ideas, ideas that have been tested and have been passed, and dispenses with those that have been tested and have failed, are too vague or to be tested at all. Fallibilism is also the guiding principle of free, open, liberal, secular societies. If the laws of nature can be wrong, then how much more fallible are our social and political arrangements? Even our morals, for example, don't reflect some absolute truth, God-given or otherwise. They are hypotheses, biological and cultural attempts to solve the problems of cooperation and conflict inherent in human social life. They're tentative, provisional, and capable of improvement. They can be and have been improved upon. The awareness of this possibility, allied to the ambition and to seize the opportunities it represents, and the scientific ability to do so, is previously what has driven the tremendous social, moral, legal, and political progress of past centuries. Fallibilism is a notion that we may not be right. Doesn't mean we must be entirely wrong. It is not a license to tear everything up and start again. We should respect tried and tested ideas and institutions and recognize that our attempts to prove on them are equally fallible. Nor does fallibilism lead to anything goes relativism. The notion that there is no way to distinguish good ideas from the bad. On the contrary, fallibilism tells us that our methods for distinguishing better ideas from worse ideas and urges us to use them to quantify our uncertainty and resolve it. Better still, to work together. Our opponent is no doubt mistaken, but in all likelihood, so are you. So why not see what you can learn from each other and collaborate to see further? Anyone wishing to understand the world of change is for better should embrace this fundamental truth. When I first read this about 2-3 years ago, I was very much impressed by it and thought it worthy to recount to you. Anyway, let's go to what I call the lunar delusion. There's a nice book, The Atlas of the Moon, and it's got beautiful maps in of the moons. Just concentrate on the moon craters. You know, they're all nicely circular. You know, even the close-ups are nicely circular. So from both, my conclusion, both Ptolemy, who was geocentric, and Copernicus, who was heliocentric, were mistaken, and modern science has it all wrong. This is the only conclusion I can reach if I have to believe academic science that the moon craters were formed during the late heavy bombardment era 4.1 to 3.8 billion years ago. Because of the total lack of side-swiped craters, we conclude every meteorite collided with the moon perfectly radial. This implies that the moon to be the center of the universe, thus we live in a lunar-centric universe. Or, which is what I believe in, we must abandon the delusional theory of late heavy bombardment, and as a consequence, the theories that postulate the formation of solar system, planetary formations, etc. Now let's have a look at Saturn. This is a nice picture of Saturn that I found on the internet. It was taken in July 1913, and in the bottom picture, just above the line, there's a small little dot, which happens to be the Earth moon as such. So NASA tells us. But anyway, if you look at the picture here, you can see the area of interest, and they discovered in 2006 what they called propeller moons, or propeller-shaped moons. They postulate these to be tiny moonlets in that area, and basically that the ring system, all the rings are rotating, so in the one side, it would be in the inner circle, which is, but it is accelerating, and in the outer circle, it is decelerating the ice particles of the ring, and thus forming these propeller-shaped disturbances. Let's look at another, in the Kepler gap, we see it's a bit further outside of the first area was here, and now we're about here. There is this moon Daphnis, which is only 8.6 by 8. That should be 8.5 instead of a S times 6.4. Why do I say kilograms? That's kilometers. So that should be kilometers. But interestingly, these disturbances here are about 4 kilometers high. Now, if you think that the ring thickness is only about 10 to 40 meters, this is a huge deviation. And I don't know of any gravitational law which this moon could exert on the rings to form an upward movement. Things get even stranger. Now, instead of being out here, we're on the inner ring. They have discovered these vertical structures as tall as 3.5 kilometers, so as pretty much as high as these disturbances we saw in the earlier picture. And this thing rotates around. There's a nice sort of time-lapse video which shows that this whole system rotates around the moon. Now, the scientists believe that there are, I'll read this, Cassini scientists believe that this is one prominent region of the ring where large bodies or moonlets up to kilometer or more in size are found. It is possible that these bodies significantly affect the ring material streaming past them and force a particular upward in a splashing manner. You know, come on, you know, it is this notion of having to explain everything, is a notion that we should try and get rid of. You know, when I was managing projects and somebody was late or phoned that he couldn't make a meeting, I first had to hear a long excuse why he can't make a meeting, which is of no concern. The only thing that was of interest was that he couldn't make a meeting or couldn't deliver or something, which is what is only of interest to me. And this is the only interest to me here is that there are unexplained deviations. But to say that we got splashing on these ice rings, which are about 30 meters thick, I think is a bit far-fetched. Then, interestingly, we've got warped galaxies where the galaxy plane is no longer a plane. It is basically like a pancake that is being flipped. And even our galaxy is warped. This image, which I found on the internet, is a superposition of a side-on view of some other galaxy, and the green dots that you see are actually mapped stars, how they which warp our own galaxy, the Milky Way. So a very interesting observation, which nobody really knows why. Which brings me to this book, Gravitation. I came across this book, I think it was 75 or 76. I was basically, it was 76 it was. And I remember in the bookstore going through it, and when I read a book, I sort of open, or basically in the bookstore, I open random pages and I read in, and then another random page, and basically that's how I decide if I want to buy a book. Ah, you've got it there. Good, Doug. Now, Doug, open it on page 1067. And there we read, the worthy theories are those which satisfy three criteria for viability: self-consistency, completeness, and agreement with past experiment. And we flip the page, and on completeness we read, the complete theory of gravity must be capable of analyzing from first principles the outcome of every experiment of interest. It must therefore mesh with an and incorporate a consistent set of laws for electromagnetism, quantum mechanics, and all other physics. No theory is complete if postulates that atomic clock measure the interval d tau constructed from a particular metric. Atomic clocks are complex systems whose behavior must be calculated from fundamental laws of quantum theory and electromagnetism. No theory is complete if it postulates that the planets move on geodesics. Planets are complex systems whose motion must be calculated from fundamental laws for the response of stressed matter to gravity. When I read that back in 76, I put the book down again, and I was astounded that somebody could spend this huge amount of effort to write 1,000 pages and then basically say, well, look, forget all these 1,000 pages. It is not a complete theory or a worthy theory. Now, is relativity self-consistent? And basically, let's just go on to special relativity, and we pull two equations from special relativity. What I marked here as equation 1 is how light transforms between a moving and between the two co-moving systems. And the second result is the kinetic energy have I got this right? Yeah, the kinetic energy, mc squared over that factor minus 1. The iconic equation equals mc squared comes from the next paper that was published after the first, this is I think the 5th paper of the series of the 1905 papers. And the paper begins with a body stationary system in E0 that emits 2 photons, so a half L plus a half L. And then Einstein shows how these transform to the co-moving system. Instead of E0, he uses H0 for the energy in the co-moving system as that. And then he asserts that the difference E0 minus H0 and E1 minus H1 is the kinetic energy, which then leads to what's marked here as equation 5. And, sorry. And basically, by equating the equation 5 of this paper and the equation 2 from the previous paper, that the kinetic energy equals mc squared, it's very simple to deduce the E equals mc squared. Basically, here it would be L equals mc squared. Now, I would like to conduct a thought experiment with you. And instead of using Alice and Bob, I always use Steve and Monica. Steve in the stationary system, and Monica in the co-moving system. So the first 2 letters, ST for stationary and Monica, MO for moving. So basically, Steve observes the decay of a 2-photon decay, and he can calculate using the Planck energy frequency, not calculate energy frequency. What's it? It's not equation, it's the relationship. He calculates what is the frequency of the photon is as fs1 and fs2. And the total energy before and after the 2-photon decay remains mc squared. Monica is in the co-moving reference frame with a constant velocity parallel to Steve's frame, and she sees the frequencies FM1 and FM2, which come out of, basically, this is defined in Einstein's paper, and the sum of the energy of the 2 photons is calculates to this, and basically for Monica, the energy before and after also remains mc squared over 1 square root 1 minus v squared over c squared. So we basically have not done anything different to what Einstein has done to get his E equals mc squared. But now we do something. Monica now uses 2 perfect mirrors to bounce these photons back to the origin, and her energy doesn't change because she doesn't see a change in the frequencies of the reflected photons. On the other hand, Steve sees the frequencies change, which is below, which is basically the same as the frequencies of a police radar. This is how the police measure the speed by applying this type of formula. Thus, in the stationary system, we have mc squared plus 2 delta mv squared over that factor. You know, since when do experiments in the one frame show no change, and in another reference frame show some change? So to summarize, we have before the reflection, Steve sees mc squared, Monica sees mc squared over the square root of that factor, and after reflection, Steve sees a bit more energy, and Monica's energies remain the same. Now, Jeffrey Hardy, who we all know, wrote very nicely in a mathematical apology, reductio ad absurdum, which Euclid loved so much, is one of mathematicians' finest weapons. It is far finer gambit than any chess player. A chess player may offer the sacrifice of a pawn or even a piece, but a mathematician offers a game. Well, Mr. Einstein, I would say checkmate to you on this. You know, we can't have it all the way, one way or the other way. And so, you know, we basically, in my opinion, this proves to me that special relativity is not self-consistent. Now, really would like to know what Max Planck, who was editor of the Annalen der Physik in that period, would have done with Einstein's theories if this contradiction was shown to him. Anyway, let's go to electrons. I have discussed this previously at the Anpa meeting, and I have refined my thought experiment. We have an electron gun, EG, that emits high energy electrons. You know, so we have an electron beam going along here. In the section A to B, we accelerate the electrons, and basically between B and C, the potential is the same. We see that we've got the battery in the opposite polarity, so there is no change of energy here. In other words, if the kinetic energy of the electron changes between A and B, current in the battery must flow, discharging the battery. And then basically, we go to the next page. Between C and D, we have exactly the opposite happening. So what do we have? We have a continuous current flow here and a continuous current flow there. And electric current is supposed to be electrons, according to Paul Drude. Well, where do these electrons that discharge this battery and charge this battery come from and go to? Which to me is completely inconsistent to the theories. Anyway, that is enough griping on I can bring out many more examples, like the photosphere of the sun, which is heats up as we go off 2-3 kilometers above the sun's surface. But anyway, Project Poincaré. This is what I want to talk about. Poincaré wrote, forces of any origin whatsoever may be explained in one or two ways. Either everything in the universe would be of electromagnetic origin, or this aspect, shared as it were by all physical phenomena, would be a mere epiphenomenon, something due to our methods of measurement. The paper is on the dynamics of the electron, which he wrote in 1906. Now, this is basically that we should really think what he has said there. Now, I'll give you some food for thought as I was criticizing special relativity. If I have a photon in 4 dimensions, now please look at, although we see a 3-dimensional figure here, this axis here combines x and y. Therefore, that intersect is velocity square root vx squared plus vy squared. I've got the z-axis along here with vz, and on the vertical, I've got the u dimension, the fourth dimension. Basically, a photon would always, in these 4 dimensions, propagate at the speed of c. If it only propagates parallel to the u-axis, it would be stationary in the 3 dimensions. If it propagates as we have it here, there would be a velocity in the xy dimension, and if it propagates only in the xy direction, we have an electron. Now, with very simple geometry, we can basically, we need to bring in the momentum of a photon is, oops, wait, let me just get back to here. The is energy over the energy of the electron divided by c, and then we can basically we follow this. So we've got an x, the momentum in xyz is E0, which would have been the momentum if it was only here, and as it gained v over c squared minus v squared. Now let the photon gain a bit more momentum in xyz, and we can calculate a delta momentum as E0 over c dv c squared minus v squared. And if we recall Newton, we come to this, and it really does not require a genius to come to mc squared equals E0 over 1 minus v squared over c squared, which demonstrates in this, in a 4-dimensional reality, that electromagnetic waves exhibit mass. But we live in 3 dimensions. I propose what I call the propeller solution to the Maxwell's equation. Now, this propeller's got nothing to do with the propeller disturbances we saw on the Saturn rings earlier. The first 2 lines of phi here are basically the Maxwell equations, derived wave equations. Then I propose that the cross product H times E times of and a scaling chi or chi to bring the units to a velocity vector as such, and basically the path would be the integral in dt. Now, why I call it a propeller solution is because if we look at the electric field, it's x cos omega t plus y sin omega t, and basically, and at right angles to it, we have h x sin omega t minus y cos omega t. Now, either of those equations would describe a point of a propeller on an aeroplane. On the provisor that we have the same equations as a function of distance, and we have this third requirement that the path s equals, in this case, along the z-axis, c times t. You can very quickly put these values into here, and you will see that this is correct. This is basically a photon, but we can extend this to 2 dimensions by defining E and H as such. Then we have H cross E equals sine omega x sine omega t y sine omega t plus, and we have the cos squared terms plus sine squared terms, which is 1. Therefore, the path is now c x cos omega 1 t plus y sin omega t divided by omega 1. which is basically a circle or a hula hoop. In 3 dimensions, I can do the same. I've got to basically the show the equation forms, and H cos E would be x cos omega 1t cos omega 2t plus sine omega 1t cos omega 2t plus z sin omega 2t. And you will recognize these as the polar coordinates of a sphere as such, and this always evaluates to 1. Now, if we do a trigonomical reduction of E and H, and we introduce a symbolic convention E sub xy I omega t, basically mapping the complex E I omega t into x cos omega t plus y sin omega t. Of course, I can put in here also other dimensions, and the trigonomical reduction of this comes to these 10-term reductions. And basically I showed this in orange because normally we have the electric field leading the magnetic field, and for the orange ones we have the magnetic field leading the electric field, very much like in a motor generator type situation. Basically, the orange terms I would call that counter matter, because if I bring these two together, it has the opposite momentum, and basically this opposite momentum allows. Okay, here I'll just show what has changed in my definition. It is basically that minus there has moved to there, and basically there's a sign change in the Faraday's and the and Maxwell's law of the Maxwell equations. Now, if we plot this, we find the path. If you evaluate this integral, we can draw very interesting curves. So, and there are 2 forms of it. The left-hand picture, we've got the ratios omega 1, omega 2 as 7 to 29, which forms a sort of circular, or not circular, spherical shape. But we can never reach the poles. And then basically with omega 1 and omega 2 is 1 and 2, where we have these, this looks very much like a tennis ball curve, and 3, and with 1, 3, we have the, now I've actually, and all of these are orbits that share a common center. Now the right-hand part, you can see the difference here. We have this this inverted or end-to-end funnels or whatever as such. Now I can propose these as a possible model for atom. So if we take the first curves and we basically rotate the blue curve by 90 degrees, we have this curve, and this would be the s orbits, and I can have 2 electrons each on their own orbit. So the one, if the one electron is up there, the other one would be opposite down there. As this moves that way, the bottom one would be moving that way. So when this one comes up to the top, this one would have moved to the bottom to there. And this would explain why the S shell has only got 2 electrons. Now, if we look at the P shelf, which this was the with using the frequency terms 1 and 3, and rotating the one by 60 degrees. So we then have independent, well, 2 independent orbits. Each of these orbits we could fit in 3 electrons. So basically, I think it was easier to see on the previous page here. We've got this. We've got these 3. Basically, the orbit is down there, through there, up there, down there, etc. You can trace it out yourself. But we've got, unfortunately, I didn't plot the diagram, but looking from the top, one would sort of get a triangular type of projection of it. So basically each of these orbits can carry 3 electrons. So it is basically the two of these orbits would give us a 6 shell. Similarly, we can now see why we've got the next orbit shell with would be a factor with 5, so which gives us a 10 electrons and 7 electrons. Now, finally, I would like you to consider basically a phi with as a function of time and path, where the path is simply ct as we had previously. Then the wave equation c squared grad squared phi minus d phi dt reduces to c squared partial d phi ds minus partial d phi dt equals 0. And if we assume 2 waves in superposition, we can, this equation holds. I've done nothing to, because phi 1 is plus phi 2, I can pull them apart. It actually works, and it is very easy to demonstrate with phi 2, which would be the circular orbit, or rather phi 1, which would be these be a circular orbit, and phi 2 a photon, this one in the z direction, this on xy. Then it's very easy to demonstrate that the superposition of phi 1 plus phi 2 exhibits relativistic mass. If I just go back to these orbits, it's a bit more difficult to show that the spherical orbits exhibit mass, is because by defining that the wave is always an exchange of energy between 2 energy forms, one must need to prove that by where this is stationary, we always see if once this thing starts moving, I can show it's basically the problem arises that the energy is no longer balanced. But one can get, in other words, that the resonance cannot hold, because the say the electrical energy becomes more than the magnetic energy. But that can be solved by invoking vacuum fluctuations, so that one resonates with vacuum fluctuations, which I have done. I must just write it up nicely. Now, basically, I'm at the end of my talk. So if we think of Poincaré's vision of 1906, my proposal to the group here is the formation of an Anpa subsidiary organization with the primary aim as a group collaboration to pursue Poincaré's grand vision. Thank you very much.
Wow. Okay. Anton, do you want to stop sharing?
Yeah, I must just get to it. There we are.
Okay. Great. John.
Sorry, trouble unmuting. Anton, Steve and Monica, you're looking at a couple of different frames where Monica has a mirror, which is basically a dye mirror, which is rigid in her frame and is co-moving with Monica. Let me just explain why there's a difference between the energy the fact of non-conservation energy in Steve's frame and Monica's frame. Look, what Monica sees is a couple of mirrors moving with Monica. What Steve sees, he sees a mirror box moving towards himself. Now he's emitted 2 photons, and those 2 photons are like a mass. Now that mass is about to be hit by a giant mirror, which looks like a moving hockey stick, which is going to bash these 2 photons with. You have to consider the whole system. Now, if you consider the whole system, then you'll find that, of course, the energy of those 2 photons increase by bashing them with something which is moving with respect to Steve, and it's moving by exactly that amount. And if you calculate it, you'll find that's exactly the amount that Steve sees of the extra energy.
No, you can't. Look, I've pondered about this problem very much. You know, you can consider, let's make them light mirrors so that the mirrors absorb some momentum, you know, and change their energies. It doesn't work because every time I set the mass differently to these mirrors, the equation changes. You know, and if I set
No, you're
the
right. I mean,
mirrors at infinite mass,
that's
then there
correct.
is no change. If I couple the mirrors, I actually only, you know, let's look at the mirror as a, you know, coupled with a bar on the top. Then there is a slight difference in energy. Most of the, you know, which is the difference in the 2 frequencies that Monica sees. It doesn't, I cannot get this to balance. So basically, if you think otherwise, I would gladly see your
Okay, look, I'll just
in terms
I'll just do
of
it.
on paper
Okay,
to study it. Your
okay,
verbal explanation I do not accept.
I'll just do it straight away. Look, imagine the 2 photons have almost 0 energy, and the light mirrors are moving at half the speed of light. And what happens is you have very low frequency photons, so let's say 2 far infrared photons, which are moving from Steve. One of them encounters a mirror which is traveling really rather fast towards it. So it hits that mirror and it gets quite a lot of energy from that mirror because of the co-moving, because it's traveling at a fairly high speed. So that photon is created from almost nothing to something which is very significant. The other photon, on the other hand, catches up with the other mirror, but it's moving away from it, so it gets to even lower energy, which you can forget about. So from going from almost no energy to a very large, to a relatively large energy quite quickly. I mean, the sums are quite easy.
No,
So,
no, I disagree. I disagree with you there. You know, I can understand why you want to maintain your stance on it, because by admitting what I've said there, and you know, show to me in formulas to change my mind. You know, if you can't show to me as in formulas to change my mind, I will remain and say that is wrong. You know, I have nobody. I shown this to a professor in South Africa, you know, at the university when I was there a couple of years ago when my mother passed away. And, you know, he went through it. You know, it was quite interesting. You know, I had it all written up and, you know, he read it through once. Then he turned to the, you know, it was basically explained on 2 pages. He then started in the beginning, took a pen, put a tick against each equation. You know, he ticked it off and agreed. And then he came out with the standard argument that Einstein, there are always some intrigues. I have to discuss this with my friends. I've reminded him twice about that he should tell me what these intrigues are. The third, I didn't bother a third time, because if he doesn't want to answer, it means that I checkmated him. And basically, the only way that I will accept your argument is you give it to me on paper as such. Otherwise, I do not accept it. Maybe somebody else wants to talk about it.
Okay, well, let other people talk at the moment, but the argument's already up there if you want to have a look at it in terms of the stuff that I gave on Quisicle in terms of, well, or that Martin gave also in terms of the reflection of photons in a box.
Look,
So
I remember
there's a
Martin's
talk, a paper up
statement
there.
when I met him for the first time, unfortunately for the last time in Belgium, and he said, "Why do you want to change it? It works." Yes, as an engineer, I don't want to change anything that works. I don't want to change any software that I use, but I'm constantly battling with changes in software that other people think that I should have. But here we're talking about the fundamentals of nature, you know, and in my opinion, the fundamentals of nature as we think about them are wrong, you know, and we should accept that and not take the stance, why change something when it works? You know, can you explain to me the diffusion of a boron gas say in the semiconductor industry, when you have a gas and this very tight structure of silicon, that atoms get drawn in. How do they get drawn in? By electromagnetic differences, in my opinion. And I can show you examples why it is. The industry has made very nice empirical equations to describe this process as an engineering process. I am an engineer and I understand that fully, but it does not explain why it is happening. Yeah, there are a lot of unexplained things about that people ignore very much. In the Vigia conferences, I'll get that paper out and put it on the internet, is the Italians demonstrated, what do you call it, alchemy, or the transmutation of elements by taking a steel bar and oscillating it with a piezoelectric, and they actually claim to see neutrons being emitted. And after running this thing for overnight or day or two, they show that the nicely polished steel bar has got blemishes in it, and in these blemishes they find materials that are not their original, or elements that are not there originally. So there is some, they then explain this on distorted space-time. And in my opinion, they made this huge mistake by trying to explain something, and people say, "Oh, this the explanation is a nonsense." Instead of and ignoring it, instead of going out, we have found this. Help us explain it. You know, I can carry on forever. And John, I don't agree with your explanation. So please show it to me in writing, and we'll and then convince me that it is not true. Maybe somebody else will want to comment. Nicola.
Nicola,
We
you have
can't
to
hear
unmute.
you. Unmute.
So I just wonder, have you, you know, as I said to you, I remember, you know, my friend Francois Chatelain was irate that Einstein had won out and was convinced that Poincaré was right. So I'm just wondering whether you have actually gone to any French academics, because obviously we know that when it came to Newton and Leibniz, the English, you know, the English mathematics was set back 100 years because the English mathematicians wanted to follow Newton's rather difficult formulation, whereas the Germans had wonderful Leibniz symbolism, which we still use. So not being in a position really myself to be able to say one way or another, I just wondered whether you know, that might be a possibility. Have you followed that?
No, I haven't followed that. Look, Poincaré, there's a number of things that I like what he has said, you know, and it is interesting. Einstein only quoted him once, you know, or mentioned him once in all his papers, and that is in the paper Geometry and Experience. And I've used that part. Unfortunately, I can't find Poincaré's original paper where he described that. But to me, basically, what he said there is that we take a geometry, you know, in Einstein case the space-time geometry, and then we formulate a purport of laws that work with this, and then we choose, we choose some laws with it, and then we must make sure that all the other laws, follow suit as not to have contradiction. So, using that model, I've actually used it at Anpa a couple of years ago. We can choose any geometry and any purport of initial laws, and then define everything from it. And the question is, which is more logical or not? And in my opinion, we don't, the way that we have it, with everything that is, that we see, especially now in the last couple of years in space, the supernova, first there were explosions like granite, grenades. But they're actually beautiful structured explosions. Have you looked at them? You cannot explain them in terms of explosions. It is a transformation of some or other wave structure that is happening there. Otherwise you can't get these symmetrical structures in space called hourglass galaxies, etc.
Sounds good, but yeah.
Okay.
Yeah.
Sorry, Nicola, do you want to carry on?
No, I mean, all I was going to say was that I follow Althusser and believe that reality is overdetermined, i.e., that there are many different explanations for the same phenomenon. And so, I mean, which is why, of course, science is never true. Science is only ever as good. A scientific theory is never true. It's only as good as its last testing. So, and that's why people try to create obscure experiments. So that's all. It was just like a saying that. I mean, I'm sorry I did come late. My grandson only left about 5:30. So, but even so, I do get out of my depth in the physics to actually be able to have a serious opinion one way or another.
No, I think just in physics we've built, or the physicists built such a huge house, or castle, which they don't want to demolish, and they can't make everything work. It's a known fact that quantum mechanics and gravity just don't work. Now they're all looking for the so-called graviton.
Yeah. Well, absolutely. I mean, Colin was talking about the same thing yesterday, wasn't he? In fact, that there are things that don't
I haven't
work.
seen his talk yet.
Right.
I basically had to look after my grandchildren yesterday.
Yeah. We grandparents. Okay.
Anyone else?
Mark, when we're still all here, are we having an AGM today?
No, tomorrow.
Oh, it's tomorrow, so of course, I'm a day out.
You can have it today if you want.
Sorry.
I don't think it make much difference, because as far as I can see, the idea of the AGM is not to change anything at the moment, because we don't know what it would
Thursday should be Friday, shall we?
What?
Define Thursday should be Friday. I'm sorry.
Yeah, exactly.
It's fine. It's fine.
Yeah.
Yeah. This business of explanation is so. I mean, we tend to fight over explanations, don't we? We tend to say, my explanation is better than yours.
Yeah.
And I'm very unclear as to what an explanation is. What do you think an explanation is, Anton?
Look, the explanation. Basically, everybody wants to be, justify everything. Explanation is a justification for something. The way that I see it. Why do I need explanation? You know, but basically, you know, why justify everything? You know, I'm only interested in the end result, you know, or basically the facts that are put in front of me. If I'm managing a project and somebody is late, I want to know that he's late. But you know, why he's late um, to deliver something does not help me in managing the project. It is only noise.
Mm.
You know, so you know, if I know he's going to be a week late, I can do something else in that week. You know, and basically this um, you know uh, trend, or basically we all need, or there's this huge need to explain. Maybe it's in our upbringing. You know, there's kids had to explain to the mothers why they're late for dinner, etc., etc.
Mm.
You know, instead of accepting the fact as it is.
Okay. Peter Marser, and then Lou.
Mike Horner also wants to talk.
Sorry, I missed Mike.
You've assumed, according to your formulae, certain mathematical conditions which can only hold under specific mathematical criteria. So and those criteria, if they're going to have physical meaning, have to hold as well. And so under certain circumstances, we don't really know whether that is the case. I mean, some of the calculations that my colleague Walter Schremp does, as mathematical analysis developed and became more sophisticated during its history, then there were, in order for certain to have a sort of continuous differential, then there have to certain other conditions, mathematical conditions, have to hold. Now the question is, do they? Because if they do, then that's fine. And usually one then discovers that there are corresponding physical conditions which also hold. So it does appear that the mathematics follows the physics, and the physics follows the mathematics in a truly remarkable way. That I imply to say that, in fact, that's how the universe works, and the two things in a certain sense are just particular aspects of the way that the universe works. And although we might think that we're cleverer than the universe, I very much doubt it. There's also the fact that the universe is still evolving, and so there are certain things that haven't happened, but we can't even predict what will happen. But eventually, in millennia or even tomorrow, they might actually happen. This is the way the universe is going to evolve. There will be a mathematical explanation, I believe, to go with it, but things can get really very complicated. And I think the only way to resolve most of these conditions is to say that, in fact, the universe has certain automorphisms, and there is a unique birth order automorphism, as Conway has proved in relation to mathematical analysis. So every time we're looking, we're not looking at the object itself, we're looking at the whole universe. The whole universe decides what in its next stage of evolution is going to happen, and it does. And we can only discover that by looking at what the whole universe is at its automorphisms.
Okay, Anton?
What you're saying, Peter, is that we've got no free will, and the universe decides. That's just basically what you're saying. But basically, mathematics is just a means of describing something, and we must just look if our descriptions are correct.
Okay, so these are positions, aren't they? Lou, you had a comment. Lou, you're muted.
You put forth the question, what is an explanation? And in mathematics, it just means that you know some starting points and you can explain some phenomenon in terms of those starting points that you already know. And one is looking for a good explanation often. So for example, how do you explain that there are infinitely many primes? How do you explain it? Well, Euclid gave a good proof. And a version of Euclid's proof is this, if you can see that. I show you that there is always a prime greater than any given number n, because n factorial plus 1 is not divisible by any numbers less than n. So there must be primes bigger than n, and therefore there are infinitely many primes. That's a good explanation. Everybody likes that explanation. Now you turn to something else, like Fibonacci numbers, and you use your computer and you find out that there seem to be always larger Fibonacci numbers. But nobody knows an explanation for that. That may be false. But if it were true, how would you explain that there are infinitely many Fibonacci numbers that are prime? And many, many other things. And on top of that, we know that if you set a given mathematical system, fix it, then there are infinitely many truths about it that can't be reached. So explanations have a limit. They always have a limit within any given framework.
Yes.
You can't explain everything. And in physics, you can't explain the basic laws that you found. You found them, or you made a guess, like Schrödinger's equation, and there it is. And you try to explain things on the basis of it. But you can't be sure that what you're doing is consistent or complete.
And
so Wheeler's idea that you would have, that a good theory should be consistent and complete is an impossible goal, but you could hope for it.
So when physicists, because explaining a mathematical or formal system in a formal way is one thing, but explaining the physical world, we're not really explaining the physical world, aren't we explaining our perception?
When we explain anything, we're always explaining something in terms of something else. So we are assuming, just like mathematicians do, some collection of things as given, and we're explaining in terms of them. I don't see any other use for any other meaning for the word explanation.
Okay, all right.
Maybe somebody else has another meaning for the word explanation.
This is the whole thing of like trying to get, a baseline of actual agreement of the common notions, which, within mathematics is pretty good. Within verbal language in the world is like, has not happened a lot.
Well, but if I say, explain yourself, why are you interested in natural philosophy? You would tell me about the context out of which you look. And those are the places where I will begin to understand your explanation.
Yeah, absolutely.
Yeah.
Absolutely. Yeah,
we do get very upset with each other about our conflict. And that's an interesting thing in itself. I'm just aware I don't want to take this over because I know Mike Horner's got a question, and then Barbara's also got a
ready to
question
speak.
on Cordays. Yeah.
Okay.
Can I speak?
Sorry,
now?
John, Mike first, and then Barbara, and then John Torday.
I was given a gift by my daughter, and it's a book by two people you may have heard of, Bastin and Kilminster. And there's a two-part section which is relevant to what happened between Anton and others represented by John. The great majority of physicists, for the great majority of physicists, there is no problem in understanding the success of the theory language of classical physics. They do not have to worry how it comes about that the theory language describes the world so automatically, because there is no distinction between it and reality. In a way, we're suffering from the enormous success of classical physics. Over 3 centuries, its concepts have penetrated our common language about the world almost completely, and the resulting amalgam of theory and experience seen under the aspect of that theory has become common sense. It is identified with reality, and it has the corresponding incorrigibility. Now, I was always interested when Ted and Clive uttered this phrase, theory language, which is why this is appealing to me. And then they went on, they said, there is a trivial form of closed language which is used to describe the world, which is quite different from the theory language. This could well be called the self-authenticating language. It is commonest in religious literalism or fundamentalism, where the language is contrived to bar the way of serious inquiry by going round in circles. Open, if you like, quotes. You should pay unique attention to what it says in this book, because it is the word of God. You will find out about God in the book. Get the idea? Now, I have one final thought about this theory, this explanation thing. I think most people recognize somebody who's got their act together on a particular subject. And when they reply moderately quickly and coherently. Somebody who doesn't have their shit together goes into waffle mode. So I would say at one end, you have a tautology. At the other end, you have a full blazing waffle. And in between, you have an explanation.
Yeah. Tautologies are very interesting. Barbara.
Very simple observation. I think sometimes confusion arises because of the type of question. For me, the question why doesn't always have sense, yes?
Yes.
Why gravity? Hell, I don't know. But how it works, I may be able to work it out. And I think this is this fine line that creates a lot of confusion.
Yes, I agree. Getting the question right.
Yeah.
Yeah. John Torday.
Yeah, the one word I haven't heard is prediction. I thought the whole point of explanation was prediction.
Okay.
That's the ultimate criterion, isn't it? So I've been in a dust-up with a couple of systems theory people, and it really rankles me because, you know, there was a huge sea change in biology in roughly the early, about 1981, when molecular biology became doable by, you know, even most of us. And so there was an opportunity to actually show causality. It failed. I think it has failed because it hasn't incorporated evolutionary thought. But my point is that that's really what we're striving for, is prediction, no?
Mm-hmm. Okay, Lou? No, sorry, Lou, you're muted.
I essentially agree with John. On the mathematical level, predictions are consequences, logical consequences. So if you have a good explanation, like molecules are in the air and in the water, and then I get predictions about all sorts of behavior, and it all fits together. And if I can actually put it in a logical framework to get the consequences, then I can make new predictions. And in mathematics, the predictions become new results that you can deduce. So prediction and consequence are tied together. And maybe prediction doesn't mean quite the same thing as consequence, even though I'm touting that.
Okay. Anton, have you got any thoughts on particularly prediction? I think that's a very interesting.
Well, on prediction, an explanation, and basically also to address Michael's comment, on classical and physics versus quantum physics. There's a very nice Chinese game of gambling tops. I don't know if you've seen this. Maybe I should try and get the YouTube video up. Basically, you have a sort of a plate or a arena where you put these spinning tops in. Some are electric. Yeah, the first time I saw it was sort of electric powered tops of some sort, and now I've seen a version which is basically you just pull a string, and then these tops sort of fight out, and they get ejected out of this arena. Now, when I see that, I ask, what is the probability? Is that Heisenberg's probability, of H there? We've got lots of spinning things. We can't, because it's, to us as observers, it looks completely random because how these tops interact when they hit each other because of the phases, the difference in speed, so that it's a complete random process that we observe there. But if I would compute a model those tops with exact same surfaces and speeds and so on, I must probably get exactly the same patterns that I would see randomly as an observer. So is the Heisenberg uncertainty, and I don't like Schrödinger's clouds of where the electrons are supposed to be. It doesn't make sense to me, as I'm classical thinking. Are those tops a nice explanation of what quantum theory tries to do with some fancy or exotic explanations, i.e. The uncertainty principles, because we don't know all the starting conditions.
Okay. Lou, did you have a comment to that? You have to unmute again, sorry. It's when you type, it sounds like tap dancing mice, so I have to...
yes, of course. You should always mute me, even in the middle of speech would be good, right? Prediction goes... I'm sorry. If your theory affects your praxis, for example, my theory of the stock market, if I happen to be a huge holder, could very well affect the stock market because I act on it. Or a computer program placed into the stock market doing predictions will, in fact, and trading on the basis of those, will change the behavior of the stock market. So if the theory embedded into the praxis has predictions, those predictions may change as a result of the theory. If theory and praxis are interlocked in a cybernetic loop, and they can be, then the whole question of prediction takes another dimension.
Yeah. John?
So I don't like to get philosophical, but I will in this case, because if in fact Schrödinger was correct, and I think he was, in saying that the life force is negentropy, life begins in an ambiguity. And the whole point, in my opinion, of everything we do as mathematicians, physicists, etc., is to try and triangulate who we are and what we are. That's the whole point of the exercise. So I think it is important to have predictive approaches, because otherwise we'll never figure it out.
I sense there's a certain amount of agreement about this, isn't there?
Excuse me, Mark.
Sorry.
But on predictions, basically, it's modeling. Prediction or mathematical prediction is nothing more than a model, of experience of the past. You know, we need experience to predict.
What do you learn from?
What do you mean by learn?
Well, I'm just thinking about where you began with your presentation. It was on fallibilism, and surely it's about error.
It's about error, you know, and it's also about pointing with a curved finger like this.
Yeah. Okay, but that comes back to Lou's cybernetic loop, doesn't it?
Yeah. No, the curved finger is basically look at yourself before you blame somebody else. You know, you must always, you know, fallibilism is nothing more than always looking at what you say.
Mm.
You know, and basically looking at yourself, you know, never blame somebody, you know, but, you know, are you part of the blame?
Mm.
You know, that's why I say with always point with a curved finger.
Mm.
And, you know, that I see you liked it. And basically, you know, as physicists or scientists, you know, we should always look back at ourselves. Of what we're saying, is this still, does it all hold? And, you know, it's part of the explanation. Look at the moon, you know, the craters. Where are the side swap craters? Where, you know, should have all these meteorites hit perfectly vertical to make round craters? It doesn't hold. You know, I can show you pictures of moon craters on irregular moons, and you have circular craters on irregular surfaces. You know, it doesn't make sense. You know, so if it doesn't make sense, one should have the courage to say, hey, we need to rethink this all. You know, and this is what I want to do, say, well, let's just rethink all of it, and you know, and see what we can make of it. Can I just answer my phone quickly?
Yes, of course, John.
So when Anton mentioned fallibility in the beginning of his lecture, I gravitated to the null hypothesis, and we, you know, we're obligated to support the null hypothesis, but the way that we practice science as a binary, it has limitations. I mean, it isn't necessarily a yes or no kind of answer, but the whole point, and what I was trying to say, I think, in my previous homily, is that if all of these things need to link together in a way where you have a grand concept of what existence actually constitutes. So there have to be statistical methodologies by which we see that all of these things form a larger truth, if you will, by merging them together in some sort of a grand scheme. Ultimately, I mean, I thought that was what we were all about.
Any comments?
No, it's not good. You know, it's completely down to a halt. You know,
I'm kind of intrigued what the telephone conversation is about, but
I'm wondering if anybody's written a book about the stock market as a quantum world.
I'm sure that's been done.
I would think it should. It must have been done, surely.
It's a great title. We have to steal it and write that book.
Benoit B. Mandelbrot wrote about fractal finance. That was really interesting book. You know that one?
No, that's
a great book.
Yeah. I'm writing it down.
We were speculating on your phone conversation.
Oh, did you all hear it?
No.
No, there was my brother
Isn't
from the States.
isn't the formula that hedge funds used
I ran a little,
based on quantum mechanics?
Are you talking about the Black-Scholes equation?
The Black-Scholes equation.
But that was the thing that really caused the financial crash in 2008.
Yeah.
Yeah. Okay. Maybe this is not a good idea.
Well, that's because everything in the world is actually connected to everything else, and we have a small proportion of people who are doing things that are to the disadvantage of all the rest of the people. And unless that stops happening, then things are going to go wrong. And that's not just my opinion. If you go on YouTube and listen to Neil Chomsky, who's more or less very extensively accepted as one of the most clever people around. I mean, after all, he does have 36 doctorates.
I didn't know that, actually.
And in fact, if he goes on German television, then
it'll take half an hour to introduce him.
On German television, they always explain what doctorates you've got.
Yeah.
And so you know, by the time he got to speak, it was probably time to go off again. But I listened to him the other day, and he really is convinced, as we should all be convinced, that that the melting of the Antarctic ice cap could very easily, within the next 20 to 30 years maximum, raise the level of the seas throughout the whole world by 10 meters. And that would be the end of our current civilization.
Okay, I mean, so I mean, in a way, this stuff, the Black Scholes equation, all of these are all bad explanations. But if we believe bad explanations, they get us into really bad trouble. So,
well,
it's not just believing. If you instantiate a bad explanation into your actions, it's even worse than believing.
Yeah, of course.
Well, isn't America a prime example at the moment?
In so many ways. With apologies to our American friends here right now, and commiserations perhaps, but maybe it's not for much longer. But yeah,
we don't need to commiserate too much. I mean, we're not any better.
Sorry,
we're no better.
I know it's a disaster everywhere.
Absolutely agreed.
So we have bad theory or bad explanations everywhere.
Yeah.
Well,
and bad
explanations which have consequences which we're not going to like.
Yes.
Because basically, if we don't follow certain norms now that the natural world requires, then as a species, we will vanish from the surface of the Earth, and the Earth will continue to evolve. And it will find some explanation for somebody will go, some species that will.
But we must remember that it's all natural. You know, even if we get wiped out tomorrow with an atomic war, it is nature. We are nature. You know, we are nothing more than nature. Yeah, we're not nothing superior.
Yes, but I mean the world ran perfectly well on its own for most of the time when life has been on Earth, and it's only now when in the last 50 years when people have taken over from it, it's taken over from its self-organization, that things have started to go wrong. And that's because we as people are, I think, too arrogant. We think that what we're doing, you know, we can continue doing it, running the world our way. Well, I think the answer is no, we can't.
Yeah. Because
the world's only got limited resources. And there are a lot of us. But it's not just that. We're doing the wrong things. We're doing the wrong things. I mean, look at the have a look at the seas around the Mediterranean coast, because people are pig-headed when it comes down to it. They're full of masks and gloves, rubber gloves. The sea's becoming contaminated.
Yeah. Richard, you got a question?
Yes, so your comment on American politics.
Oh, yeah.
If any of you are dual citizens living not in the U.S., you might still be eligible to vote here, even if you don't have a residence here.
There you go. Right. Okay.
I will give you the relevant information.
I don't know if you, John Maynard Keynes is famous for making the remark, "In the end, we're all dead," and it's a very wise remark in many ways, because it, you know, obviously his discipline was economics, but when we start to rationalize or try to rationalize about this stuff, it actually gets very hard, because we're enclosed in our own physiology, our own bodies, and our own mortality. Thinking beyond that is
not so much. I mean, the people I'm sorry for, because I'm not going to last much longer, are my great-grandchildren. And their inheritance is, well, it could be hell on earth. And I have been responsible for that in some small measure. Well, perhaps
and
even a
Maynard
large
Keynes
measure.
didn't believe in reincarnation, is that right, Mark?
Sorry?
Maynard Keynes didn't believe in reincarnation, is that correct?
No, he didn't.
This leads me to a question. On this evening when we can talk about anything, when is that? Is that the very last?
This is the last day. Yeah. Do you want to talk about anything? We could tell jokes. We need to discuss what we do.
I'm going to talk about reincarnation and extraterrestrials.
Oh, brilliant! Well, that would be fantastic. Yeah, lightning talks on absolutely crazy stuff. That would be fantastic.
There you go.
Well, I think I've already told one or two of you that I can see how to, and this could be real, how warp speed can be, as in Star Trek, can be affected, because it is already affected on Earth. If you build a catamaran that will come up on stilts, then you can actually, as you turn it closer and closer to the wind, it rises out on the stilts, and it goes faster than the wind.
Well, I can watch this in front of my front stoop. You know,
and if we can do that,
Cup.
inertially in space, then we can travel at warp speeds.
And Mark, I have a technical question. When you say the talks will be very short, can you as host mute anybody if they go over time?
I can, yes, that's an interesting idea. Yes, we could do that. We could give people a timer and move from one person to the next. Yes, we can.
And may I suggest you also use this feature in ordinary meetings, not just necessarily this very last one?
Well, yeah, I've got mixed feelings, because sometimes I'm a big fan of letting the conversation go where it wants to go. And sometimes obviously people dominate and it's hard to judge. But also you do, you know, we take a while to form our thoughts, I suppose. So it's a tricky balance, that one. And we're not. Go on.
Can you devise a reward for those of us who manage to stay within our time?
Oh, now that's a
now, at the Gardner conference, they give you a quarter if you
Actually, I like that. That's very good. Yes, if you actually ask a question, I mean, you can have all sorts of fun. No, we actually do need. It would be really good to have a session. I think next Friday's session, we should experiment a little bit. One of the things that you can do, and some people have experimented with, if you, on the bottom left-hand corner of the screen, where it says stop video, if you've got your video on, if you click on the little arrow above that, you can choose a virtual background, which will basically change your background to any photograph. And you can choose a video filter, which will do all sorts of weird things. You can actually have a video background of yourself in the background, so you can actually appear twice. You can have some fun with this.
Yes, I have a virtual background right now.
Oh, well, there you go.
It's about a mile from my house on the Wissahickon Creek. It's there. You can do even more with virtual background if you get the latest edition of Zoom.
Mm-hmm.
You can put a
green screen.
I'm blanking on the thing because I never use it. It's the Microsoft program with the capital P.
PowerPoint?
Yeah, PowerPoint. You can put a PowerPoint on as your virtual background.
That's correct. So what I want to suggest, I was going to suggest fancy dress, but I think I'm going to suggest fancy backgrounds for next Friday. Okay, John Torday.
I just wanted to say, Peter Marster, I'm sorry that you corrected yourself. We could actually go at warp speed. We have to figure out who we are, because just to go elsewhere and just foment the same crap is not going to work. You know, we're the only species that knows that we know. It scares the shit out of us because we know we're immortal, and this is the problem. We have to fix that.
Oh, I agree. I'm just saying I can conceive how it could be done. It doesn't seem to, that doesn't imply that I want to do it. I don't, because it's very clear that, you know, I think I've been very lucky. Well, perhaps we've all been very lucky in relation to the period through which we've lived, and we've seen how wonderful the world can be. You know, if you've been to the Greek islands or the Grand Canyon, or been skiing early in the morning and been up on the piste just by yourself or off the piste just by yourself, and the sun is shining, and that's a heavenly experience. It's just mind-bogglingly beautiful, and why we should want to do anything to the earth to make that impossible, which to some extent we've already done, because we're all locked down, or most of us probably are. Then I just cannot think. You know, I want my grandchildren and my great-grandchildren to be able to do all the wonderful things that I've had the great privilege of being able to do during my life. I mean, when I was 18, I went to Farnborough on a sort of summer study vacation, and I went up in my first aeroplane, and one of the aeroplanes was a V-jet bomber, because it was because the guy I was working for just happened to have some associations with it, and so without not telling anybody, they dressed me up in the uniforms, and we did a circuit in a V bomber. That was and the only other time I've been, they took me up in I think a Lysander, you know, a little very much older. It was just mind-boggling.
But if our grandparents could see us now doing this, they'd be astonished, wouldn't they?
They would be astonished. I mean, this is just mind-boggling, isn't it? What we're doing. It's you know, it's the only way now I can actually talk to my great-grandchildren.
Yes.
it may be the only way I can ever again talk to my family, because if the coronavirus gets worse, then I won't dare to go out, because I'm old and I'm suffering from cancer, and have a thyroid problem among others, and my wife has extremely bad arthritis. So basically we're banned from going out anyway. In fact, I've been on lockdown for 18 months. Virtually, the only time I've been out of the country is to go to attend a medical conference in Prague, which was very nice, because Prague's again a magnificent city. It's just so beautiful, and the social things that we could do then were just wonderful. I mean, I've been extremely privileged all my life. Not because of because my father was a steel worker in Sheffield, and after the war, you could win a scholarship and be educated at the university, and live very handsomely on it. And I've been able to do more or less anything I ever wanted to do until now.
James Lovelock, speaking last month, I think it was pretty convinced that the coronavirus was a self-regulatory mechanism. He felt that this was a corrective in some way. Yes.
Well, the Earth it's not that we run the Earth runs us. We're part of it, and it knows it somehow knows what's happening to all the species on it, and all the wonderful things it's built up by self-organization, and we're going against that, and it's sent out its armies to as at least a warning, to tell us that turn back from this way, or I'll wipe you from the face of the earth.
Yeah. Barbara, did you have a question? Would you just waved your hand?
Sorry, it was a little bit like at the auction. I was.
Oh, right. Okay. No, it's exactly. No, you've just bought a 3-piece suite.
No, I was confirming the idea, because I believe in what James Lovelock says, that it's self-regulatory mechanism. It cannot be anything else.
No,
another thing is, which made me extremely sad, is that the wildlife species are in free fall. I mean, the destruction that we inflicted on Earth is unimaginable, and actually it will in the end destroy us. Think of Eastern Islands, yes. It's just, yeah, so yes.
So, but if it is a self-regulatory mechanism, what's the explanation? What's the mechanism? How does that work? I mean,
well, John probably knows better than me.
Sorry?
I mean, John Torday probably knows better than me about that.
Okay, yeah. Okay, I think we're probably done for the evening, are we? We can talk about this stuff until the cows come. But I do look forward to next Friday's meeting, when we can talk about all sorts of crazy stuff.
Yes.
And now, Lou, tomorrow you're going to talk.
Yes, I'm talking about not experiments.
Okay, so that's not doing experiments.
That's cannot experiment.
Okay, all right. And then we have the joys of an AGM, which I can assure you will be stimulating. And I know that there's some sensitivity around this, and some people feel that we need a longer meeting. I think we probably need to carry the program out as it was set out, and then as part of that, possibly arrange a special meeting to talk about some of the deeper issues, which I know have been concerning John Amson and Nicola and a couple of others, Granville. Are people okay with that? So I don't think.
Can you tell me, who doesn't know, for example, I'm sure there are others, what John Amson is worried about?
Well, I can share the emails. I can share the emails. I'm not. I think.
If I can sum it up by just reading it, I think it's just procedural, you know, that he's worried about. It's just a plain procedural thing, you know. He hasn't proposed anything to change, or so it is just a procedural conformity.
But we do have accounts, and we do have. We did have a meeting last year, which we need to, you know, look at and think about. Obviously, everything has changed this year, so we have to do that stuff. And but I don't think it will take that long. Okay, all right. Okay, Friday tomorrow. I look forward to seeing everybody then.
Lou, can we have a quick Skype talk immediately after 5 minutes?
I'm sorry, what's the question?
Can we have a quick Skype talk for 5 minutes after?
Oh, sure.
Just very
sure.
quick.
Sure. I'll open up Skype as soon as we're done here.
Yeah, I want to ask you something.
It's technology, isn't it? It's amazing. Right. Okay. I'll see you tomorrow. Okay.
Okay.
Bye-bye.
Bye.